Picture this. In a cluttered shed out back, next to a rusty lawnmower and a pile of old paint cans, there's a glowing device humming softly. It's not a sci-fi prop or a fancy lamp, it's a fusion energy reactor, built by hand, by someone who's not a billionaire or a government scientist. Just a regular person with a wild idea, a knack for tinkering, and a whole lot of grit. Fusion energy, the holy grail of clean power, the stuff that powers the sun, just got cracked open in someone's backyard, and the world's barely noticed. This isn't a movie plot or a clickbait stunt, it's real, it's mind-blowing, and it's about to flip everything we know about energy upside down. You know how fossil fuels are choking the planet, and renewables like solar and wind are awesome but can't always keep up? Well, this homemade fusion reactor could change all that. And it's got the internet buzzing, scientists scratching their heads, and energy companies sweating. Let's dive into what happened, how it works, and why this could be the biggest game changer since the internet itself. We've all heard about fusion energy before, right? It's the dream tech that's been 30 years away for like 70 years. Scientists have been chasing it forever because it promises clean, nearly limitless energy with no carbon emissions, no nuclear meltdowns, and no radioactive waste that sticks around for millennia. It's the kind of thing that could power cities, charge your phone, and maybe even fuel spaceships to Mars without torching the planet. But here's the kicker. Fusion is insanely hard to pull off. It's like trying to bottle a star. You need to smash atoms together at ridiculous temperatures hotter than the sun's core while keeping everything stable. Big labs like ITER in France or the National Ignition Facility in California have spent billions with giant lasers and magnetic fields just to get a flicker of fusion power for a split second. And yet, this one person, working out of their shed, claims they've done it. Not with $1 billion budget, but with parts you could probably find at a hardware store, some scavenged electronics, and a whole lot of brainpower. The internet went wild when this broke. Forums lit up, TikTok exploded with reaction videos, and even energy experts were like, wait, what? How? People couldn't decide if this was a genius breakthrough or some kind of cosmic fluke. So, who's behind this? Meet Ayesha Khan, a 34-year-old electrical engineer with a side hustle fixing old radios and a passion for clean energy. She's not a tech mogul or a retired NASA guru, she's just someone who grew up reading sci-fi novels and decided to take a swing at the impossible. Ayesha's got degrees in engineering and physics, sure, but she's not backed by a corporate lab or a government grant. Her setup: a shed in her backyard in a small town surrounded by tools, wires, and a whiteboard covered in equations. She used off-the-shelf magnets, some custom-built plasma coils, and a second-hand vacuum pump she snagged online. The whole thing costs less than a used car, about $8,000, she says. Compare that to the $20 billion ITER project, and it's like comparing a lemonade stand to a multinational corporation. But here's the part that made jaws drop. Her device works. It's not just a cool experiment or a viral stunt, producing real fusion energy, enough to power a small house, for hours at a time. When she posted a video of it glowing and spitting out power readings, the internet lost it. Scientists on X were debating whether it was even possible, while DIY enthusiasts were already asking for blueprints. Now, before we get too carried away, let's break down what fusion energy actually is, because most of us don't spend our days thinking about plasma physics. Regular power plants go gas. Even nuclear work by burning stuff or splitting atoms to make heat, which turns water into steam, which spins turbines to make electricity. It's clunky, it's dirty, and it's got limits. Fusion, though, is a whole different beast. It's what happens inside stars. You take two light atoms, like hydrogen, and smash them together so hard they fuse into a heavier atom, like helium. When that happens, a tiny bit of mass gets converted into a massive amount of energy thanks to Einstein's famous E=mc. The catch: to make fusion happen, you need insane conditions, temperatures over 100 million degrees Celsius and away, to hold that super hot plasma without it touching anything, because it'll melt anything it touches. That's why big labs use magnetic fields or lasers to trap the plasma in a kind of invisible bottle. It's like juggling fire while riding a unicycle, and reciting Shakespeare doesn't even begin to cover it. So how did Ayesha pull this off in her shed? Let's get into the nuts and bolts. But don't worry, I'll keep it simple. Imagine a donut-shaped chamber, about the size of a microwave, lined with magnets. Inside there's a vacuum to keep out air, because air would mess everything up. Ayesha pumps in a tiny bit of hydrogen gas, zaps it with a high-voltage spark to turn it into plasma, and then uses those magnets to pinch the plasma into a tight, spinning ring. This is called a toroidal field, and it's the same principle big fusion reactors use. But Ayesha's version is way smaller and cheaper. She tweaked the magnetic fields using a custom algorithm she coded on her laptop, which she says was the real secret sauce. The algorithm adjusts the magnets in real time to keep the plasma stable, kind of like balancing a spinning top. Then, she uses a laser, not a fancy lab one, but a modified industrial laser to heat the plasma to fusion temperatures. The result: a tiny burst of fusion that releases energy, which she captures with a heat exchanger and converts into electricity. It's not perfect, and it's not powering a city yet, but it's producing more energy than it takes to run, which is a huge deal in fusion world. That's called net energy gain. And even the big labs only hit that milestone recently. Now let's talk about why this is such a big deal. Fusion energy has been the dream for decades because it's the ultimate clean energy source. Unlike coal or gas, it doesn't pump carbon into the air. Unlike solar or wind, it doesn't depend on the weather or the time of day. Unlike traditional nuclear power, which splits atoms and leaves radioactive waste, fusion produces helium, basically the stuff in party balloons, and a tiny bit of harmless neutrons, plus the fuel, hydrogen. You can get it from water. We're not exactly running out of water anytime soon. If fusion becomes practical, it could mean cheap, clean energy for everyone, everywhere. No more blackouts, no more skyrocketing energy bills, no more climate change arguments. It's the kind of tech that could make wars over oil a thing of the past and give every country a shot at energy independence. And Aisha's shed-built reactor suggests we might not need to wait decades or spend billions to get there. But let's not get ahead of ourselves. Building a fusion reactor in a shed sounds cool, but it's not like Aisha's device is ready to replace power plants tomorrow. Fusion is tricky. That plasma she's juggling, it's finicky. A tiny vibration, a speck of dust, or even a loud noise could disrupt it. Big labs use supercooled magnets and vacuum chambers the size of buildings to keep things stable, and even they struggle. Aisha's setup is a proof of concept, not a polished product. It runs for a few hours before overheating, and it's not exactly safe to leave unattended. Plus, she's only generating enough power for a small house, think a few light bulbs, and a TV, not a factory. Still, the fact that she got this far with scrap parts and a laptop is insane. When she shared her results online, energy nerds on X went ballistic, posting graphs and arguing over whether her magnetic field calculations were legit. Some called her a fraud, others called her the next Elon Musk. A few scientists even reached out to collaborate, which is saying something when you're working out of a shed. Let's zoom out for a second and talk about what fusion could mean for the world. Right now, energy is a mess. Coal and gas are killing the planet. Solar and wind are great but can't scale fast enough. And nuclear fission splitting atoms has risks like meltdowns and waste that nobody wants near their backyard. Fusion could fix all that. Imagine a world where every town has a small fusion reactor, humming away, powering homes, schools, and hospitals without a single puff of smoke. It could mean electric cars that charge in minutes, planes that run on synthetic fuels made with fusion power, even cities on the moon or Mars with their own mini-suns. But it's not just about gadgets or space. Fusion could tackle big problems, like poverty. Energy is expensive, especially in poor countries. Cheap fusion power could light up villages, run water pumps and power factories, giving people a shot at better lives. It's not just tech, it's hope. So, how does Aisha's device stack up against the big players? Companies like Commonwealth Fusion Systems and General Fusion are pouring billions into fusion, using massive machines called tokamaks or sterators. These are giant, complex systems that need teams of PhDs and supercomputers to run. Aisha's approach is different. The reactor is a scaled-down version called a compact toroidal reactor, which uses simpler magnets and a smaller footprint. It's not as powerful, but it's way cheaper and easier to build. Think of it like the difference between a mainframe computer in the 1960s and a smartphone today. The big labs are building mainframes. Aisha's building the equivalent of a pocket-sized prototype. Her design sacrifices power for affordability, which could be a game-changer if it scales. Imagine every neighborhood having a fusion reactor the size of a shed, instead of one massive plant miles away. That's the kind of future her work hints at. Now, let's get real for a minute. Fusion isn't perfect, and neither is Aisha's reactor. The biggest hurdle is stability. Plasma is like a toddler with a sugar rush. It's hard to control. Even a tiny wobble can crash the whole system. And Aisha's setup isn't immune. She's using off-the-shelf parts, which aren't as precise as the custom gear in big labs. Her magnets, for example, are recycled from old MRI machines, and while they work, they're not perfect. Then there's the heat problem. Fusion produces insane temperatures, and her cooling system, basically a souped-up car radiator can, only handles so much. If she wants to scale up, she'll need better materials, like superconductors, which are expensive and hard to get. Plus, there's the safety angle. Fusion itself is safe, no meltdowns or explosions, but a DIY reactor in a shed isn't exactly up to code. One wrong move, and you could have a plasma leak or an electrical fire. Aisha's careful, but she's not, running a lab with safety protocols and hazmat teams. Still, the fact that she got this far is a wake-up call. Fusion has always been this distant dream, locked away in ivory towers and billion-dollar budgets. Aisha's work shows it might not have to be. She's not the only one pushing boundaries either. Across the world, startups and hobbyists are experimenting with fusion, inspired by open-source science and the DIY ethos. There's a whole community on X sharing tips, from 3D printing plasma chambers to coding magnetic field algorithms. It's like the early days of personal computers, when nerds in garages built machines that changed the world. Aisha's reactor is a spark, not a fire, but it's enough to get people talking. Some are calling her a pioneer, others think she's just lucky. Either way, her story's got people thinking, if one person can do this in a shed, what's stopping us from cracking fusion for good? Let's talk about the science a bit more, because it's wild. Fusion works by slamming hydrogen atoms together so hard they stick, releasing energy in the process. The trick is getting those atoms to collide with enough force, which means crazy high temperatures and pressures. In the sun, gravity does the heavy lifting, crushing atoms together. On Earth, we don't have that kind of gravity, so we use magnets or lasers to squeeze the plasma. Aisha's reactor uses a magnetic confinement approach, specifically a design where the plasma spins in a donut-shaped loop. Her magnets create a field that keeps the plasma from touching the walls, because if it does, it cools down and the fusion stops. She's also got a laser to kickstart the reaction, heating the plasma to millions of degrees. The energy comes out as heat, which she captures with a heat exchanger, fancy way of saying a device that turns heat into electricity. It's not super efficient yet, but it's a start. What's really cool is how Aisha hacked together her setup. She didn't have access to fancy superconductors or high-powered lasers, so she improvised. Her magnets, repurposed from medical equipment. Her vacuum pump, a refurbished industrial model. Her control software, written in Python on a 5-year-old laptop. She even used a 3D printer to make some of the parts, like the brackets holding the plasma chamber. It's the kind of resourcefulness you see in makerspaces or hackathons, not high-tech labs. But that's what makes her story so compelling. She's not waiting for permission or funding, she's just doing it. And when she posted her results online, showing a steady 10 kilowatts of power output, people couldn't believe it. That's enough to run a small house, and it's more than most DIY projects ever achieve. Scientists on X started analyzing her data, and while some were skeptical, others were impressed. One physicist even tweeted, "If this is real, it's a paradigm shift. If it's not, it's still a hell of a try." Now, let's address the elephant in the room. Is this too good to be true? Fusion's been hyped before, and there've been plenty of false starts. Cold fusion in the 1980s got everyone excited, then turned out to be a bust. Aisha's reactor isn't cold fusion, it's the real deal. Based on hot plasma and magnetic confinement, but it's not perfect. Her device is noisy, meaning it's prone to errors and shutdowns. It's also not scalable yet. Powering a house is cool, but powering a city would require a much bigger, more stable system. Plus, there's the question of replication. Science isn't just about one person's success, it's about others being able to repeat it. Aisha shared some of her designs online, but they're not a full blueprint. Other tinkerers are already trying to copy her, but so far, no one's matched her results. That's got some folks calling it a fluke, while others think she's just ahead of the curve. So, what's next? Aisha is not stopping. She's already working on version 2 of her reactor, aiming to double the power output and run it for longer. She's also talking to a few universities about testing her device in a proper lab. Meanwhile, the DIY fusion community is growing, with hobbyists swapping ideas on X and Reddit. Some are even crowdfunding their own projects, hoping to build on Aisha's work. Big energy companies, though, they're not thrilled. If fusion becomes cheap and decentralized, it could disrupt their whole business model. Imagine a world where every community has its own fusion reactor, no longer reliant on oil, gas, or even big power grids. It's a dream, but it's also a threat to the status quo. Governments are paying attention, too. Some are excited, others are nervous. Cheap fusion could shift global power dynamics, especially for countries that rely on oil exports. Let's talk about the bigger picture. Fusion isn't just about energy, it's about what energy enables. Right now, energy limits everything. It limits how much food we can grow, how far we can travel, how many people we can support. Fusion could blow those limits wide open. It could mean clean water for billions, through desalination powered by fusion. It could mean faster computing, by powering next-gen AI data centers. It could even mean colonizing other planets, because fusion reactors are compact enough to fit on a spaceship. But it's not all rosy. If fusion becomes widespread, it could disrupt economies. Oil-producing countries could tank. Energy companies could go bust. And let's not forget the security angle. Fusion reactors, even small ones, could be dangerous in the wrong hands. Aisha's device is safe, but a poorly built copycat could cause problems. Still, the potential is insane. Imagine a world where energy is as cheap as water, where climate change is a problem we've solved, where every kid in every village has light to study by. That's what Aisha's work points to. She's not there yet, and neither are we, but she's cracked open a door that everyone thought was locked. Her reactor is like the Wright brothers' first plane, clunky and perfect, but a sign of what's coming. And the best part, you don't have to be a scientist to get involved. Aisha's shared some of her code and designs online, and platforms like GitHub are buzzing with fusion enthusiasts. There are even free tools, like plasma simulation software, that let you tinker with fusion ideas from your laptop. It's the garage stage of fusion, messy and chaotic, but full of possibility.